Think of an API like a waiter at a restaurant. You sit down, look at the menu, and tell the waiter what you want. The waiter takes your request to the kitchen prepares your food, and the waiter brings it back to you. In this scenario, you are the client. The kitchen is the server, and the waiter is the API. You don't need to know how the kitchen works, you just need to know how to ask for what you want. One of the most common types of API is called a REST API. REST stands for Representational State Transfer. Now, that sounds complicated, but the idea is simple. It's a standardized way for applications to communicate over the internet using familiar web technologies. If you've ever opened a website or used an app, you've already used REST, you just didn't notice it. REST APIs rely on HTTP methods, the same ones your browser uses every day. GET is used to retrieve data, like asking, "Show me all users." POST is used to create something new, like adding a new account. PUT is used to update existing data, such as editing a profile, and delete removes data, like deleting a post. These four operations form the foundation of most modern applications. Let's say you're building a social media app. When a user opens a profile, your app sends a GET request to a server, endpoint something like users. 1. The server processes that request and sends back the user's data, usually in JSON format. JSON is lightweight, easy to read, and perfect for transferring structured information. One of the most important features of REST is that it's stateless. That means every request is completely independent. The server doesn't remember what happened before. While that might sound limiting, it's actually powerful. Because the server doesn't need to track each user's history, it can handle millions of requests at the same time, making REST highly scalable. Now let's compare that with another type of API. SOAP. If REST feels like a quick and casual conversation, SOAP is more like a formal legal agreement. Everything must follow strict rules, with no room for deviation. SOAP messages are written in XML and follow a rigid structure. Every message includes an envelope that wraps everything, a header that contains metadata like authentication, and a body that holds the actual request or response. This strict format ensures consistency but also makes SOAP heavier and more complex. So, why use SOAP at all? Because it's extremely reliable. It has built-in standards for security, error handling, and transaction management. That's why industries like banking, healthcare, and government systems still rely on SOAP, where precision, trust, and guaranteed delivery are critical. Next, let's talk about RPC Remote Procedure Call. RPC allows your program to execute a function on another machine, as if it were running locally. For example, you might write getUser123 in your code, and behind the scenes, that request travels across the network, runs on a server, and returns the result. gRPC is a modern evolution of RPC, designed for speed and efficiency. Instead of using text-based formats like JSON or XML, it uses protocol buffers, a compact binary format that's much faster to send and process. If REST is like sending a handwritten letter, gRPC is like sending a compressed digital file instantly. It also uses HTTP/2, allowing multiple requests to share a single connection. Another powerful feature of gRPC is its support for streaming. It allows simple request-response communication, continuous data streams from server to client, streams from client to server, and even full two-way communication in real time. This makes it ideal for high-performance systems and real-time applications. Now, while REST is simple and widely used, it has limitations. Sometimes it sends more data than you need. This is called overfetching. Other times, you don't get enough data and need multiple requests. This is both cases can slow down your app and waste resources. GraphQL solves this problem in a completely different way. Instead of relying on multiple endpoints, you send a single query describing exactly what data you want. For example, you can request only a user's name and email, nothing more, nothing less. The server responds with precisely that data. GraphQL also includes powerful features like real-time subscriptions, allowing your app to receive updates automatically. It's also self-documenting, meaning developers can explore and test the APIs using built-in tools. Now let's talk about a different approach, webhooks. Normally, apps keep asking servers for updates over and over again. This is called polling. Webhooks flip that model. Instead of constantly asking, you give the server a callback URL. When something happens, like a payment or a new message, the server sends the data directly to you. No repeated requests, just instant updates. Webhooks are widely used for automation. They power notifications, payment systems, CI/CD pipelines, and integrations between apps, keeping everything in sync in real time. WebSockets take real-time communication even further. They create a persistent, always open connection between the client and the server. Once connected, both sides can send data at any time without needing to reconnect. This makes WebSockets perfect for chat applications, live dashboards, multiplayer games, and stock market updates. Finally, we have WebRTC enables direct peer-to-peer communication between devices without relying on a central server. It's the technology behind video calls, screen sharing, and real-time collaboration tools. It automatically handles networking challenges, adjusts quality based on connection speed, and delivers fast, secure communication directly between users. Each API style is designed for a different purpose. REST is simple and scalable. SOAP is strict and reliable. gRPC is fast and efficient. GraphQL is flexible and precise. Webhooks are even. WebSockets enable real-time communication, and WebRTC allows direct peer-to-peer interaction. Understanding these differences helps you choose the right tool for the job and build better, faster applications. If you found this helpful, don't forget to like and subscribe so you won't miss the next one. It really helps to support the content, and let me know if you want more videos like this. Thank you for watching.